Hi Year 10. By the end of this lesson, you should be able to use congruent triangles to prove conjectures about quadrilaterals. That word conjecture means a guess. If you have a guess about quadrilaterals, you should be able to prove it using congruent triangles. Here's the kind of thing I'm talking about. I want you to prove that if the opposite sides of a quadrilateral are equal, that it is a parallelogram. If the opposite sides of a quadrilateral are equal, then it's a parallelogram. What if you've got a four-sided figure where the opposite sides are the same length? Is it going to be a parallelogram? The obvious thing to do is to start by drawing a diagram and try and get it so it looks like the opposite sides of the figure are the same length. So that's my four-sided figure, that's a quadrilateral. It's my bad diagram. And what I'm trying to do is to show that this side is equal to that side and that this one is equal to that one. So is it true that if those sides are equal, that this is also a parallelogram? So can I mark those with chevrons to say that I've got two pairs of parallel sides as well as two pairs of equal sides? Well, that's the question. Let me start by getting a better diagram. That diagram that I just drew was rubbish, so let's fix it by doing one that I did. And here's one I prepared earlier. It's like a cooking show. Right. How are we going to prove that this good diagram, now that I know has two pairs of equal sides, because I drew it that way, how am I going to prove that that is a parallelogram? That this side is parallel to that side, and this side is parallel to that side. Well, we can prove things, but we can only prove it when we're talking about congruent triangles. So if we divide this shape up into triangles by drawing in a diagonal, and there's my diagonal, let's pretend that's a straight line. Well, maybe I should use the straight line tool. There you go, there's my diagonal. Can I now prove that that figure has parallel sides? Well, let's go with triangles. Let me label the corners. That's going to be A, that's going to be B, that's going to be C, that's going to be D. Is there anything in there that would allow me to show that the sides are parallel? Well, there's a giveaway to me. I know I'm a maths teacher, but I can see that that is a Z. And if you've got a pair of angles that make a Z, they are alternate angles. And if alternate angles are equal, then the lines that make it up must be parallel. So the top and the bottom lines will be parallel if that angle is equal to that angle. Can we prove using these two triangles that those two angles are equal? If we've done that, then we've shown that the top and the bottom are parallel. Well, if these two triangles are congruent, then the angle here, BAC, is going to be the corresponding angle of DCA in this triangle, and those two angles must be equal if the two triangles are congruent, if they're the same size and the same shape. So I'm going to prove that triangle ABC is congruent to triangle CDA. And I'm going to use that to prove the parallel line conjecture that we've got. So let's do a quick proof. In triangle ABC and triangle CDA, that's keeping the letters right, CDA. Now I'm going to use what sort of proof for this? I've got this sides are the same, those sides are the same, and this side is common. So it looks like a side, side, side proof. So let's do one. I'm going to say first side, AB is equal to CD. How do I know? It's given, I've got dashes on it. It says that the sides of this thing must be equal. The other sides I know are AD and CB. So AD is equal to CB. I know they're equal. They've got dashes on them. it says opposite sides are equal. It's given to me in heaps of ways. And then this side, AC, is common. Therefore, triangle ABC and triangle CDA. Oops. It's not just and, it shouldn't be an and, it should be an is congruent to. So, one. Therefore, triangle ABC is congruent to triangle CDA. So I know those two triangles are congruent. So I know that this angle in the bottom triangle is equal to this angle in the top triangle because they are corresponding angles. So I can say, therefore, angle BAC is equal to angle DCA. The reason I know that is that corresponding angles in congruent triangles are equal. Okay, therefore, AB is parallel to, and that's my symbol for is parallel to DC. And the reason is that alternate angles are equal on parallel lines. Alternate on parallel lines. Now, that means that I can put chevrons on the top and the bottom line. But I'm not just interested in the top and the bottom line. It says it's a parallelogram. A parallelogram must mean that I should be able to put chevrons on BC and AD as well. BC should be parallel to AD. Well, how would you prove that? Can you see a Z that involves BC and AD? There is a Z there. There's alternate angles. Let's do them in a different colour. So the alternate angles are here and here. And so using the triangles that I've already proven are congruent, I can just do these two lines again. So I can say, therefore, or maybe and would be a better word there. Let's go back to this and say and. What are they? Angle DAC is equal to, not congruent to, is equal to angle BCA. And the reason is the same as this one. Corresponding angles in congruent triangles are equal. And therefore, AD is parallel to BC. AD is parallel to BC, because alternate angles are equal on parallel lines. So that means that I can draw my chevrons in now. And if I've got two pairs of parallel lines, that means that my figure ABCD is a parallelogram. Therefore, ABCD is a parallelogram. And that's what we set out to prove. I drew a diagram that looked like the edges were the same length. I didn't know the sides were parallel, but by drawing in a diagonal, you can find congruent triangles and use alternate angles to prove